Hi guys, today we're going to take a look at question 4 of the 2017 exam, paper 2. Okay, so the points A, B, and C are 3 points on a circle, and we want to find the equation of that circle. Okay, so straight away let's just get our points down. A is the origin, 0, 0. B is the point 6.50, and C is the point 10, 7. Okay, so we're looking for the equation of the circle. So the first thing we might think to do is to write down the equation of a circle. So the equation of the circle is of the form x minus h squared plus y minus k squared equals r squared, where hk is the center and r is the radius of the circle. Okay, so and these x and y, they're points on the circle. So if we put in a point of the circle xy, so if we have given xy on the circle, if we put those values of x and y into this equation of the circle, into here, then we should get the radius. Because let's say we took the square root of both sides, the square root of x minus h squared plus y minus k squared. Well, you might actually recognize this as the distance formula. And so this is the distance from the point on the circle to the center, which, as we know, that should be r. So you square both sides and you get the equation of the circle. Okay, so that means if we put in our points on the circle into this equation, well, then we should have the equality given. So if we put in x and y equals a equals 0, 0, then we get h squared, because x is 0, plus k squared equals r squared. Okay, and so that's for x and y equals a. If we let our x and y equal b equals 6.50, then x minus h, 6.5 minus h squared, plus, again, k squared, since y is 0, should also equal the radius squared. And then finally, if we let x and y be c, this point be c, which is 10, 7, then we should get that 10 minus h squared should equal to, plus 7 minus y squared, 7 minus k squared should equal the radius squared. Okay, and so, well, if we notice, we have 3 equations here. We have 3 equations, and we have 3 variables, h, k, and r. So we can do a simultaneous equation. So let's write down our 3 equations. One is h squared plus k squared equals r squared. 6.5 minus h squared plus k squared equals r squared. And then our third equation, 10 minus h squared plus 7 minus k squared is equal to r squared. Okay, so now we have this system of simultaneous equations, and we want to solve for h, k, and r. Okay, so, well, we notice we have a k squared here and a k squared here. So if we minus equation 1 from equation 2, so 2 minus 1, then we get, well, equation 2, on the left-hand side, we'll get 6.5 minus h squared, so 6.5 squared, minus 13h, 2 by 6.5, plus h squared, plus k squared, and then minus the left-hand side of equation 1, h squared plus k squared. And this will equal the left-hand side, the right-hand side of equation 2, r squared, minus the right-hand side of equation 1. And we'll notice that lots of things here are going to cancel. So the h squared will cancel with here, k squared will cancel with here, and this r squared will cancel. And all we'll be left with is 6.5 squared is equal to 13h if we bring this 13h over. And then this will allow us to solve for h very nicely. We just divide by 13 and we get h equals 6.5 squared over 13, which will be 6.5 over 2, or 13 over 4. So h is 13 over 4. So we've already solved for h. Okay, and now we need to use our other equations. So, okay, so now we're going to use equation 3 minus equation 1. And so the left-hand side of equation 3, 10 minus h squared, well, that will give us 10 squared, 100, minus 2 by 10h, minus 20h, plus h squared, plus 49 minus 14k, plus k squared, minus the left-hand side of equation 1, h squared plus k squared. And again, this will get rid of the h squared and k squared. And then this equals right-hand side minus right-hand side, r squared minus r squared. So again, we get rid of the r. So this h squared will cancel, this k squared will cancel, and the r squared will cancel. So this is actually making it very easy for us. So now we've got 100 minus 20h plus 49 is equal to 14k. Okay, but we actually know what h is. It's 13 over 4. So we'll have 149 minus 20 times 13 over 4, or 20 by 13 over 4 is equal to 14k. So this is a 149 minus 65, which is 84, equals 14k. And so if we divide by 14, we get k equals 6. So now we have k. Okay, so now we have h, we have k, and this will allow us to get r. So if we look at just equation 1, then h squared, 13 over 4 squared, plus k squared, 6 squared, is equal to r squared. Okay, and so this will give us 169 over 16 plus 36 equals r squared. So r equals the square root of 169 over 16 plus 36, which equals the square root of 745 over 4. Okay, so now we have h, we have k, and we have r, so we can put this into our equation of the circle, and we get the equation of the circle is x minus h, 13 over 4, squared plus y minus k, 6, squared equals r squared. So if we just square this term here, then we should get square of the numerator, 745, over the square of the denominator, 4 squared, 16. And so that's our equation of the circle. So the important thing here is just remembering the equation of the circle and using these 3 points to form a system of simultaneous equations, which we can then go about solving in the standard way. And it's really not so bad from there, especially if you can pick which equations to use. So for example, we used 2 minus 1 and 3 minus 1 to cancel as many things as possible. That will make it easier. Now on to part B, find the angle BCA. Give your answer in degrees correct to 2 decimal places. Okay, so first of all, let's just visualize what the angle BCA might look like. So we know that the point A is on the origin, and B, so this is A, B is about 6.50, so it's on the x-axis, and C is the point 10.7, so maybe something like here. Okay, and so we're looking for, so this is C and this is B, and so we're looking for this angle BCA. So this is our theta. We're looking for this angle theta. So just visualizing it, that might make it easier. And so we're looking for the angle between the lines BC, or let's just say the lines AB and the line BC. And so we have this this formula for the angle between two lines of slopes let's say MAB and MBC. So we have that tan of this angle is equal to plus minus let's call this one of the slopes, MAC. This should be between the lines AC and BC, not AB. So the angle between this line and this line. So MAC minus MBC all over 1 plus the product of them. Okay, And now, well, this begs the question, what are the slopes of these lines? And that should be fairly easy to figure out since we have this slope formula. So given 2 points on the line, the slope between the slope of the line between these 2 points is y2 minus y1 over x2 minus x1, where x1, y1 and x2, y2 are the 2 points you're looking at. So if we're looking at AC, well, A equals 0, 0. So if we let that be x1, y1, and C equals 10, 7, then the slope between them, MAC, is equal to 7 minus 0 over 10 minus 0, so just 7 over 10. Okay, and now looking at the slope of BC, so B is our x1, y1, which is 6.50, and we have the same C equals x2, y2, so we'll let this be x1, y1 now. Then this slope MBC, so y2, 7, minus y1, 0, so just 7, over x2, 10, minus x1, 6.5, and this is just 7 over 3.5, which is just 2. Okay, so these are our two slopes, MAC and MBC. So then if we just put that into our formula, then tan of our angle is equal to plus minus MAC, 7/10, minus MBC, minus 2, over 1 plus MAC, which is 7/10, by MBC, which is 2. And we can just do tan inverse of this, so theta equals tan inverse. Well, we've got to think, is this a plus or a minus? Well, actually, you know what, let's just worry about that later. Let's just put it in as a plus, and if it looks like we ought to change it, we can do that. So 7/10 plus 2 minus 2 over 1 plus 7/10 by 2 equals minus 28.44. And so we're clearly not looking for a minus angle here, so it is the minus this. So 28.44 degrees is our angle, the angle BCA.